Hey everyone, this is Dr. Pranjali Sharma, and in this video lecture I am going to teach you Rolle's theorem in differential calculus. So what is Rolle's theorem? According to the theorem, if a function fx is continuous in a closed interval AB, if the function is differentiable in open interval AB, and if f of A is equal to f of B, then there exists C which is between A and B such that f dash of C is equal to 0. So by an example I will show you how can we verify Rolle's theorem. So I am taking an example. So verify Rolle's theorem for fx is equal to sin x upon e to the power x in the interval 0 to pi. So first we show that these three conditions are satisfying. Then we find a C which will be between A and B, and f dash of C will be 0. So since sin x is a continuous function in interval 0 to pi, and e to the power x is also continuous in interval 0 to pi, therefore sin x upon e to the power x is continuous in closed interval 0 to pi. Similarly, we all know that sin x is differentiable in range 0 to pi, as well as e to the power x is also differentiable in the range 0 to pi. Therefore, sin x upon e to the power x is differentiable in range 0 to pi. Next, we find f of A and f of B and show that f of A is equal to f of B. So, f of 0 is sin 0 upon e to the power 0, which is equal to 0. And we can see that f of pi is sin pi upon e to the power pi, which is 0 upon e to the power pi, which is also 0. Hence, we can see that f of 0 is equal to f of pi. Therefore, we can apply Rolle's theorem in this function. So, there must be a C between A and B. There must be a C which is between 0 to pi such that f dash of C is equal to 0. So since fx is sin x upon e to the power x, therefore if we differentiate it, we can get e to the power x square, e to the power x, differentiation of sin x is cos x minus sin x e to the power x, which can be written like e to the power x cos x minus sin x upon e to the power x whole square. So it will be cos x minus sin x upon e to the power x. Therefore, f dash c is equal to 0 gives us cos c minus sin c upon e to the power c is equal to 0. So let's find value of c and check whether it lies between 0 to pi or not. So since cos c minus sin c upon e to the power c is 0, that means cos c minus sin c is equal to 0. That means cos c is equal to sin c. Divide both sides by cos c. We obtain tan c is equal to 1, and in the range 0 to pi the value of 1 is tan of pi by 4. Therefore c is equal to pi by 4, and we can see that pi by 4 is lying between 0 to pi. That means c is between 0 to pi, and f dash c is equal to 0. Therefore, for function fx is equal to sin x upon e to the power x, the Rolle's theorem is verified. Next, I will show you another example of Rolle's theorem. Next, we will solve another example of Rolle's theorem. So, in this example, we have to verify Rolle's theorem for the function fx is equal to e to the power x into sin x minus cos x in the range pi by 4 to 5 pi by 4. Alright, so first we satisfy three conditions. Since we know that e to the power x is a continuous function in this range, and we know that sin x minus cos x is also continuous in the range pi by 4 to 5 pi by 4. Therefore, if two functions are continuous, then their product is continuous. We all know that. That's why the function fx, which is equal to e to the power x sin x minus cos x is continuous in interval pi by 4 to 5 pi by 4. In similar way, we can show that e to the power x sin x minus cos x, since both the functions are continuous in range pi by 4 to 5 pi by 4, therefore their product is also differentiable in interval pi by 4 to 5 pi by 4. Next, we show that f of a is equal to f of b, where a is pi by 4 and b is 5 pi by 4. So first we find value of f of pi by 4, which is equal to e to the power pi by 4 sin pi by 4 minus cos pi by 4, which is equal to 0. And f of 5 pi by 4, which is equal to e to the power 5 pi by 4 sin of 5 pi by 4 minus cos of 5 pi by 4, which is also 0. Hence we have shown that f of pi by 4 is equal to f of 5 pi by 4. Therefore, we can apply Rolle's theorem over here. So, we find a C which is between pi by 4 to 5 pi by 4 such that f dash of C is equal to 0. So, first we find f dash x. Since fx is e to the power x into sin x minus cos x. Differentiate both sides with respect to x. We'll get f dash x on left hand side, and on right hand side we use differentiation's product formula. So first function differentiation of second. So differentiation of sin x is cos x and differentiation of cos x is minus sin x, plus second function differentiation of first. And it can be further written like e to the power x as common, cos x plus sin x plus sin x minus cos x. So it is equal to 2 e to the power x sin x. So if we use the formula f dash c is equal to 0, it gives us 2 e to the power c into sin c is equal to 0. So we can write it as sin c is equal to 0, and in range pi by 4 to 5 pi by 4, the value of sine is 0 at the angle pi. So it can be compared with sine pi, hence value of c will be pi. And we can see that pi is between pi by 4 to 5 pi by 4. Therefore, we have shown that f dash c is equal to 0 and c is between pi by 4 to 5 pi by 4. Hence, Rolle's theorem is verified for fx is equal to e to the power x sin x minus cos x in range pi by 4 to 5 pi by 4. So in this video lecture, I have taught you about Rolle's theorem and how to verify Rolle's theorem for different questions. So keep practicing, keep watching. Thank you. Hey everyone, this is Dr. Pranjali Sharma, and in this video lecture, I am going to teach you Lagrange's mean value theorem in differential calculus. So according to Lagrange's mean value theorem, if a function fx is continuous in a closed interval AB, and if the same function fx is differentiable in open interval AB, then there exists a value C between A and B such that f dash of C is equal to f of B minus f of A upon B minus A. So next I will show you some examples to verify Lagrange's mean value theorem. So I am taking an example to verify the theorem. So the question is verify Lagrange's mean value theorem. Lagrange's mean value theorem for fx is equal to log of x in interval 1 to e. So we check the conditions. So we all know that log x is continuous in the range 1 to e. So we write log x is continuous in range 1 to e. Similarly, log x is differentiable in open interval 1 to e. Therefore, according to Lagrange's mean value theorem, Lagrange's mean value theorem, there must exist a value C between A and B such that f dash of C is equal to fb minus fa upon b minus a. So let's try to verify the theorem, and we have proved upper two conditions. So we find fb, fa and f dash of c and put in equation 1. So since A is 1, B is E, so f of A, which is log 1, that is 0, and f of B, which is log E, that is 1. And since f dash of x, which is differentiation of log x, that gives us 1 by x. Therefore, f dash of c is 1 by c. Put all values in equation 1. So f dash x is fb minus fa upon b minus a. So we put x is equal to c. So 1 by c is, we have found fb as 1, fa as 0 upon b minus a, that is e minus 1. So 1 by c is 1 upon e minus 1. That gives us value of c as e minus 1. And we can obviously see that the value of c, which is e minus 1, is lying between these two values 1 to e. Therefore, we have shown that f dash c is equal to f of b minus f of a upon b minus a, where c is between a and b. Therefore, we have verified Lagrange's mean value theorem. So in this video lecture, we have learned what is Lagrange's